Now in this video we will be discussing about probability. So first of all we will be discussing what is sample space. So sample space is set of all possible outcomes of an experiment denoted by S or ohm. Right. Suppose I conduct an experiment and I throw a dice. I might get 1, 2, 3, 4, 5, 6. These all are my sample space, right? Any element of sample space is said to be sample, and any subject of the sample set is called an event, right? Now, suppose I am tossing a coin once. So, I am tossing a coin once, sample space will be either head or tail. I am tossing a coin twice, sample space will be either head with tail or head, either tail with head or tail, right? Suppose I am throwing the coin thrice, then head with tail, right, and then head, tail, and then head, tail, and then alternative head, tail, tail, head, tail, right? None of them will be repeated as you can see. So this means if I threw coin n times, my sample space will be 2 to the power n. Why? Because a coin can give either head or tail, and I am throwing it n times. So the sample space will be 2 to the power n. Here it was 2 to the power 3, 8. Here it was 2 to the power 2, 4. Right. Now, for throwing a dice, once I will throw a dice, I will get 1, 2, 3, 4, 5. I am throwing dice twice. So I will get 1, 2, 3, 4, 5, right? And then 2 with 1, 2 with 2, 3 with 4, right? And same with 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. So overall, a dice can give 6 numbers, and I am throwing it n times. So sample space for throwing it n times will be 6 to the power n, and in this case it is 6 to the power 2, 36. Right. Now we will move to combination. So what is combination? Suppose I have whole number set from 0 to n, right? So n factorial is n into n minus 1 into n minus 2 into n minus 3 up to 1, right? Suppose there are n number of different things and we want to select r number of things at a time, and the order does not matter. So it can be written as combination of n and r, right? It is defined as n factorial by n minus r factorial, right? This is what we call combination of n and r. Now there is an interesting thing you can see. Combination of 0, n is equal to combination of n, n. Combination of 1, n is equal to combination of n minus 1, n. Combination of 2, n will be equal to combination of n minus 2, n. Right. Why this is happening so? Because if we see, there is 0. Suppose I have n different things, right? I want to arrange in 0 ways. So there is only one way, that is nothing. There are n things and I have to arrange all. So there will be only one possibility, right? All 52 decks of card, right? So it is theory that the sum should be equal to n. So here 2 plus n minus 2, it will give n. 1 plus n minus 1 will give n. 0 plus n will give n. So this is the theory, and I have to write. So this is clearly 1, right? This is n factorial by n minus 1 factorial, 1 factorial. This can be also written as n, right? Simply n, and then this is written as n factorial by n minus 2 factorial, 2 factorial. This is written as n into n minus 1 by 2. How I am writing like that? You can see this is n factorial, this is n minus 2 factorial. So what is left? N into n minus 1 by 2 factorial, right? Similarly, I have this c n comma 3 or c n minus 3 comma 3, right? This is written as n factorial by n minus 3 factorial, 3 factorial. This is written as n into n minus 1 n minus 2 by 3 factorial, right? This is what we have discussed till now. So drawing two cards from a shuffled card, this can be written as C52, 2, right? Or drawing 3 cards from 52 cards can be written as C52, 3. Drawing all 52 cards can be written as C52, 52. These all are sample space, right? These all are my sample space, right? Now let's discuss a question. I am removing this board and let's discuss a question. Suppose I have a number line 0, 1, 2, 3, 1, 2, 3, minus 1, minus 2, minus 3, minus 1, minus 2, minus 3, right? Now my question is, suppose there are points a comma b is to be selected, right? A, b is from minus 2 to 0. Here 0 included, minus 2 included. Suppose this is b, right? And a is from 0 to 3, right? This is here a, right? So any point, either this can be a point, this can be a point, this can be a point, this can be a point. My question is here, the question given is here, find probability that distance d between a and b is greater than 3. So basically distance d between a, suppose this is a, this is b, so the distance between a and b is greater than 3, or distance can be simply written as a minus b is greater than 3. Suppose anywhere a is x, anywhere b is y, so this is x minus y greater than 3. Now let's take a line x minus y minus 3 is equal to 0. X is equal to 0, then y is equal to minus 3. So here y is equal to minus 3. Y is equal to 0, then x is equal to 3. So here, right? Right. So suppose I get a reason, right? The reason I get x minus y greater than 3 and x intersect 3, y intersect y minus 3, and this cuts the rectangle. So where the, this is valid here, right? Because 0, suppose I take here 0, 0. So 0 minus 0 is not greater than 3, but here I take, suppose 3, right? 3 minus 2. So this is true, right? So this area is my favorable area, and this area is area of triangle half, right? Half base into height, and overall area of rectangle is 6, because 3 minus 2, so this is 6. So the probability will be event by total sample space, that is 2 by 3, that is 1 by 3, right? And then next question, a point selected at random inside circle, find probability that point is closer to circle of to the center of circle than its circumference. Suppose this is my circle, right, and the radius is r, at distance r by 2. When I get here, I will be closer to center. When I will get here, I will closer to circumference. My question is, find probability that point is closer to center of circle than its circumference. So this area I have to consider. This is area is pi r square by 4. This complete sample space area is my pi r square. The favorable area by total area, right? This is 1 by 4. So the probability of me being closer to the center of circle than its circumference is 1 by 4, right? Now, what is definition of probability? Let S be sample space set of an experiment A, B an event, and then probability of A is P of A will be A by S, right? And suppose phi is impossible event, so probability of impossible event is 0. Probability of any event will lie between 0 and 1. Now, what is suppose there are two events A and B. So what is A union B? A union B is simply either A, right, or B. This whole area. A intersection B will be simply A intersection B. This is this area, right? And A minus B will be simply this A complete, and the part that B is covering, that will be removed. So only this area is A minus B, right? Now, mutually exclusive events. Suppose there are two events A and B. I threw a dice, I got 2 once, and one time I got 5. But these two events cannot happen at same time. So that's why these two events are mutually exclusive. They do not have any common point, right? So events like this which don't have any common point are called mutually exclusive event. Suppose this is A and this is B, right? Now, there are some axioms and theorems. So probability of any event A can lie between 0 to 1. Probability of getting a sample space is always 1, right? And probability of A union B is equal to probability of A plus probability of B if A and B are mutually exclusive events, right? Similarly, probability of A1 union A2 union AN will be written as probability of A1 plus probability of A2 plus probability of A3 up to probability of AN if all events from A1 to AN are mutually exclusive events, right? Now there are some theorems, so I am turning this on another side to explain theorems. First theorem is complement rule. So what complement rule says? Probability of A complement is equal to 1 minus probability of A. So how to prove this? This is my sample space, this is A, and this is A complement, right? Now I know probability of A, A plus A complement will give me sample space. Probability of sample space is 1. Probability of A plus probability of A complement, and from here I am getting this, right? This is complement rule. Now subset rule. So subset rule, what does it says? If A is a subset of B, then probability of A is less than equal to probability of B. Suppose A is a subset of B, then suppose this is B, right? And this area is B minus A, and this is A. B minus A union A can give me, right, can give me B. Yes or no? Right. So if I apply probability, this will give us, and both are mutually exclusive, right? So this will give me B minus A plus P of A and P of B. So this probability lies from 0 to 1. So that's why I can say probability of B is greater than equal to probability of A. Right. Now difference rule. Difference rule is probability of A minus B is equal to probability of A minus probability of A intersection B. Now suppose this is my sample space, this is A, this is B, right? This is my A intersection B. This is my A minus B. Can I say A minus B union A intersection B can give me A? Then probability of this and probability of this will give me A minus B, which can be written as P of A minus P of A. This is written as this plus this, and simply I will write simply this as, right, this I will write as P of A minus P of A. No, this is, wait, this is how I wrote this, right? And when I will, okay, so this is what we have to prove actually. P of A minus A intersection B will give P of A minus B. So I was unnecessarily extending this, right? This is the final we wanted. And next is addition rule, right? Addition rule, this is P A union B, right? Now A union B is what? This is my A minus B and this is my B. So I can write this as A minus B union B will give me, can give me A union B, right? Simply this. So this is written as these are mutually exclusive. So this is written as P of A minus P plus P of P, and P of A minus P will be written as P of A minus P of A intersection B plus P of P, and this is what I result wanted, right? Also for three events, P of A intersection B intersection C can be written as P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of A intersection C. So now what is happening? Intersection I wanted to get, right? This is A, B, C, right? I removed this. I removed this actually. Then I again removed this, and third time I removed this, right? So what happened? Actually, I had to remove this one time, but by mistake I have removed this three times, right? So I am again adding one time probability of A intersection B intersection C to balance it out, right? This is what I get. I wanted A union B union C, right? I wanted this one time, right? But by mistake I have removed this one extra time, so that's why I have added this one, right? Because as you can see, this is A, this is B, this is C. One whole time I got A, then I got B, then I got C. Three times I got, and then three times I also removed, but I have to get that one time, so that's why I added it one time, right? This was all for this video. We will see in the next video.